through the curriculum. Okay, so I think you must be aware of all these things. I will not take you through the prerequisite. So this is the exam pattern. Okay, and this is the domain classification. For each domain, this is what exam pattern will look like.
Yep.
Okay, so for you, I will not go through PPT. Okay, because generally PPT is always high level, like you said. The in CISSP bootcamp, everything was like checklist. Okay,
Yeah.
so this is what the training looks like. For because CISSP is a big organization, they do like this. In one-to-one training, the matter is different. But I will not take you through this PPT. What I will do is I will take you through. So eighth version is quite old. It is 6-7 years old. Okay, and the current version is 10th. 10th is 2023 version. Okay, and ninth is 2021. So this is the we generally prefer this one because it covers everything. Okay, so we will go ahead with the ninth version. It covers 99.9% of the exam pattern. So what I will do with you, I will not go for each topic. What we will do, we will open. You must be already aware of this pattern. Okay, so there are 21 chapters. So what I will do for you, I will go through each and chapter line by line. Okay, so what we can do is we will cover each and every topic covered here. Okay, integrity, availability, DAD. We will discuss with you. Okay, what the topics you are not aware of or you are uncomfortable, we will discuss them in detail. I will teach you, I will make you understand. And the topics you are aware of, we will skip it or just discuss and skip it so that we cover everything in time. Okay, and because see, the main thing in CISSP is to clear exam. Okay, teaching and studying is very easy part. It is only 30%. Okay,
Yeah.
70% part is the preparation for exam because exam is very difficult. So this is the level of intensity for this exam you will have to do. See, I can only cover the pattern. Okay, what is going to come, what you should prepare, and I will help you in understanding the concepts. Okay, because in this exam there are around 2000 concepts which you will have to remember. Okay, so as we go through this exam, start preparing mind maps. Okay, as we go through this syllabus, start preparing mind maps, start connecting them, all these things with each other. We will discuss each and everything. See, this book is of 1000 pages. Okay, so covering 1000 pages in 40 hours is a difficult task. Okay,
Yeah.
so and this there are 20 questions after each chapter, so there are around 400 500 question bank in this as well. So this is what we will do, because I will also share some websites you can purchase their subscription and start preparing for exam in parallel. Okay, so we'll try to complete the syllabus ASAP and then you start preparation. Okay, so the more you appear for mock test, more prepared you are. Okay, and as soon as you start getting above 85% or 90% in your mock exam, you think that you are prepared for appearing for exam. Okay, so this is the way I teach and I suggest my students to appear for exam. For this demo session, I will teach you or I will tell you about cryptography. Okay.
Okay.
Yeah. So let's, because it was your struggling area, so let's go there only. See, this is not a technical exam. Okay, most people think, see, the person or the students who come for the training are technical people. Okay, so they work on network, they work on either they are system administrators, so their mind is technical, they think technically. Okay, so either they are working on in the security team, they are configuring firewalls, they are configuring switches, routers. Okay, and suddenly their work profile gets changed to security, or 5-10% of the security domain gets added to their profile. This is, say, I'm telling you the real facts. Okay, I'm teaching this subject from last 5 years. Okay, so
Yeah. Yeah.
so whenever student thinks that, see, some part or they have configured firewall or 5-10% of their domain is security, so they start preparing for CISSP, or they think that they can clear CISSP. Okay, so mandatory requirement for CISSP is that you should have expertise or 5 years experience in any of the two domains. Okay, working experience in any of the two domains. And
Mm-hmm.
second thing is you should have a manager mindset to appear for this exam. Okay, if you think you are an engineer or you still work like an engineer, you think like an engineer, you won't be able to pass it. Okay, because this exam won't have any technical thing. They will not ask how to configure a router, what is any command of a firewall, how to configure a firewall. This exam will have questions about firewall. It will ask what types of firewall are there, and to stop a DDoS attack, what type of firewall has to be installed. Okay,
Mm-hmm.
so you need to have a CISO mindset or a manager mindset to pass this exam. First thing is that. Okay.
Okay.
So if you want
I
to go
think.
into technical, you go for other exams like CEH, okay, Certified
Mm-hmm.
Ethical Hacker, or there are multiple exams in industry which are pure technical exams. Okay,
Mm-hmm.
prescribed by Cisco, prescribed by Microsoft, Microsoft Cloud exam, Microsoft Security exams. Okay, Azure Security. So there are
Mm-hmm.
multiple which are purely technical, but this is specially for a manager level. Okay, so there is a saying for this exam, or CISC square itself says that this is an inch deep and a kilometer long exam. Okay, this CISSP is inch deep and kilometer long. That means you will have to remember around 2000 concepts. You will have
Mm-hmm.
to have a high level knowledge of this. Most of the students who are technical, they think that CISSP is a technical exam.
Mm-hmm.
Okay, it is a managerial exam. They will test your thought process. They will test your English. Okay,
Mm-hmm.
so what do you think? How will you solve this problem? Okay, or how will you assist your team to solve this problem? How will you help design your team or your organization a security profile for your organization or for your network. Okay, so they will not ask you to implement it. You will only approve it after designing. You will have to understand all the concepts if everything is there or not. Okay, so this
So.
exam will include everything from physical security. This will teach you what type of fire extinguisher should be there, what type of security system should be there. Okay, cryptography should be there, where you should
Mm-hmm.
store your data, how you should store your data, what should be your business continuity plan, what should be your disaster recovery plans. So it all talks about managerial level thinking. Okay.
I got you.
Yeah. So this the students who generally wants to get promoted or who are on managerial position or wants to move on managerial position generally appears for this exam. But the benefit for technical people is they easily understand it. Okay. I have
Mm-hmm.
seen many non-technical people or purely IT managers or some senior managers, general managers come and study this exam. Okay. For for them to study what is cryptography is like Hebrew.
Mm-hmm.
Okay, so they don't understand it. So the benefit with the technical people is they easily understand concepts because they are working on it.
Mm-hmm.
Okay, they listen or hear all these things on their day-to-day basis.
Okay, got you.
Okay. Okay, so let me spend 15 to 20 minutes. I will give you a high level overview of what PKI and cryptographic applications is. Okay, so chapter
Mm-hmm.
6 is all about encryption and symmetric encryption and cryptography. But this PKI and cryptographic application is one level above chapter 6. So I directly came to chapter 7 because this area you said you are struggling on. Okay,
Mm-hmm.
so Mr. Atik, what idea do you have about cryptography? And let me take two steps back and start from beginning. So why do we need cryptography? Okay, see, you must have studied that there are three objectives in any security domain. Okay,
Mm-hmm.
or what is the CIA triad? Okay, confidentiality, integrity, and availability. Okay,
Mm-hmm.
so cryptography achieves at least two of these. Hmm? So availability is not in the hand of cryptography. What it can do is it can help you achieve confidentiality and integrity. Okay, so there is one
Mm-hmm.
other concept which comes here, digital signatures and hashing. So hashing helps us in achieving integrity, and cryptography helps us in achieving confidentiality. Okay.
Mhm.
So this CI triad is now bigger. Okay, so generally we have a five parts in this. So new addition in CI triad is non-repudiation. Okay, so what is non-repudiation? Non-repudiation is subject cannot deny the act he has or she has done. Okay, so let's say someone has done a mistake, intentionally or unintentionally, it can be anything. Okay, so non-repudiation help us achieve the objective that they will not be able to deny it. So how
Mhm.
do, see, to understand this you have to connect it with the normal crime. Okay, we are talking about cyber crime and cyber security. Security is required when crime is there. Okay, so if there is no crime, security is not required, right? Hmm.
Right.
So let's say there is a theft around. So how police is going to detect? Okay, police is going to take their fingerprints. Okay, so if someone's fingerprints get matched, so they will not be able to deny it that they have not done it, right? How did your fingerprint came here? So
Yeah.
non-repudiation achieves this objective. Okay, and digital signature is the digital fingerprint of an subject. Okay,
Mhm.
got it? So
Yes, got it.
yeah. Then if we talk about cryptography, so cryptography, like you said, achieves confidentiality. Okay, so how confidentiality is achieved? We encrypt something, we keep our data so that no one else can read it, and when required, we decrypt it. Okay, so there is a
Mhm.
key to encrypt it, there is a key to decrypt it. Okay,
Yes.
so now encryption or cryptography are of two types. One is symmetric encryption and other is asymmetric encryption. Okay, so what symmetric encryption is? Symmetric encryption is we have only one key to encrypt and one key to decrypt. Let's say we both want to talk to each other. Okay, you are sitting in North America and I'm sitting in XYZ place. We don't know how to communicate. If we communicate over email, our emails or messages can get hacked or someone can read in the between. Okay, so what we will do, we will exchange a key with each other. Okay, and then we will exchange the message. So you will encrypt the message with that particular key, send it to me, and then I will decrypt that message with that particular key and read it. Okay, so let's say you have to communicate with 10,000 people. So how will you do it? So 10,000 people has to communicate among each other. So each one will have their own key to communicate with each one of them. Everyone has to maintain almost 99,999 keys. Okay. So it is
Mhm.
very cumbersome and difficult to manage those keys. Okay. So this is one of the disadvantage of symmetric encryption. Okay. One of the most important advantage of symmetric encryption is it is very fast. Okay, so there are multiple encryption techniques or algorithms we will discuss in detail. I will take you only high level. So in 1970s, I think around 77, yeah, 77, US Security Department introduced an algorithm called DES, Data Encryption Standard. Okay, it was a 56-bit encryption standard. It was introduced in 1977 and everyone started following it. So it was broken or it became irrelevant in 1990s, and then US Department of Security or NIST, their National Institute of Standard and Technology, organized a world level open competition to introduce a new algorithm for symmetric encryption. And then they adopted Ringdoll encryption in 1999 and 2000, and now it is the latest standard and it is going on from last 24 years and still used. Okay, it is advanced, it is called advanced encryption standard, AES. Okay, so the other disadvantage of asymmetric encryption was exchange of keys. Okay, so if 10,000 person has to exchange keys with each other, so you can understand that every person has to exchange 9,999 keys. Okay, because 10,000 minus 1. So this is the number of keys they have to exchange. Let's say some of their keys got compromised. So then everyone has to, he has to generate new key for everyone. Okay. To facilitate the exchange of keys, one other algorithm was developed that is called Diffie-Hellman. Okay, so the objective of Diffie-Hellman is to just ensure that the key exchange is done securely. Okay, so Diffie-Hellman is not an encryption technique, it is only a key exchange technique. So we have seen that there were so many disadvantages of symmetric encryption, but it is still used because it is very fast, almost 10,000 times faster than asymmetric. Okay, so to remove the disadvantages of symmetric encryption, asymmetric encryption or cryptography was introduced. In asymmetric, what was there? Two keys are there. One is public key and one is private key. Okay, so what public
Mhm.
and private key denotes is there are, let's say you have generated your asymmetric algorithm or encryption. So you will have two keys. One will be your private key, which is only known to you. Other is public key, which is known to everyone. Okay, so whenever you have to communicate with anyone, let's say someone, I want to send you a message, a secured message. So what I will do, I will encrypt the data I want to send you with your public key, which is available online to everyone. Okay, and once the data is encrypted with your public key, it can only be decrypted with the private key you held.
Mhm.
So this is what asymmetric encryption is. So the benefit of asymmetric encryption is one person will have to maintain only two keys. Let's say I have to communicate with 100,000 people. I will have only two keys. One key is with me and one other key is with everyone else. It is available. So anyone want to communicate with me can go online, check my public key, encrypt the message and send it to me. Okay. So this is how asymmetric encryption works. Okay, so there are multiple asymmetric algorithms. One is RSA, everyone in industry follows it. Other is LGML. Okay, so there are few others. We can discuss them in detail. Okay, so I
Mhm.
explained all these things because it is the base of public key infrastructure and cryptographic applications. Okay, so now we'll come to this chapter, public key infrastructure and asymmetric encryption. Okay, so we have already seen how asymmetric cryptography works. There are two keys, public key and private key. Okay, so how the communication will happen? There is a plain text message, okay, and there is a sender. So what sender will do? Sender, let's say I have to send a message to you. I will encrypt the message using the algorithm of my choice, and not my choice, the algorithm you are using, and encrypt it with your public key. Okay, so your public key is available, the message is encrypted, a cipher text is generated. Now what you will do? You will do the reverse. But the only change is in symmetric encryption, the key here and key here would remain same. In asymmetric encryption, I am using public key and you are using your private key. Okay, and then the plain text message comes out. This is how asymmetric encryption works. Okay, any question
Okay.
in this? Let's say I have to send, or you have to send data to me, or I have to send data to you. Okay, so we both want
Okay.
to communicate. So
Okay.
if I have to send some secure data to you, I will use your public key. And if you have to send some data to me, you will use my public key.
Oh, okay.
Okay?
So, okay, got you. Got you. So, my public key and your public key is different. Okay.
Yes, 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 yes. You will
Okay.
understand it. I will show you. I will show you a live example also. Okay. I will
Okay.
show you a live
Okay.
example. You will understand it.
Okay.
Okay, so now
Sure.
coming to some of the algorithms, one is RSA. This is industry wide used. Okay, you might have heard about it, RSA, in your organization as well. Okay,
Yes.
so RSA was developed by three mathematicians, Ronald Rivest, Eddie Shamir, and Leonard Edelman. Okay, so RSA comes from here, R, S, and A. So the
Okay.
initials of their last name. Okay,
Mm-hmm.
so in 1970s when DES was introduced, they also introduced their own algorithm and they patented it. So still they are using it. How RSA works, I will not discuss it now because it is little deeper, but just to give you a high glimpse that RSA works on the principle of two large prime numbers. Okay. So they do some mathematical calculation on two large prime numbers, and large prime numbers is not like 17 or 19. Okay. So the approximate length of each prime number is around 200 digit. Okay, so you can assume how big those numbers are.
Mm-hmm.
Okay, so they will multiply those numbers and do some mod function and all those things. We will study this everything during our exam, oh sorry, during
Mm-hmm.
our training. Okay, so you can
Okay.
assume the one prime number is around 200 digit long. Okay, so then other algorithm is LGML. So LGML is an extension of Diffie-Hellman. Okay, so this is the key. Hmm. I'm not going into specifics and minute details. I'm just giving you a high level idea of cryptography. Okay.
I
So
understand.
yeah.
But my question is, do I need to remember the abbreviations like what RSA stand for,
See,
what R stand for, what A stand for,
no, no,
or
no,
I
no, no.
just need to understand the idea?
No, no. See, in CISSP exam, they don't expect you to remember RSA, the full forms or the abbreviations.
Okay.
Okay. But they need you to understand how RSA works and what is RSA, why RSA is used. RSA is a symmetric algorithm or it is asymmetric algorithm, and maybe sometimes their key length as well. Okay.
Okay. I
Yeah.
understand.
So
You
you
answer
need
my
not to
question. Yeah.
understand, learn these full forms. Okay.
Okay.
So you
Got
will
you.
always get full forms, abbreviations written in full forms in CISSP exam. Okay, always.
Mm-hmm.
Hmm. See, but in case of RSA, it is easily understood. They will not write the name of scientist. RSA is RSA. There is no abbreviation or full form to it. Okay. Hmm. So specifically talking about RSA, we will see so many abbreviations in it, but RSA is not an abbreviation. It is a name of technology or an algorithm. Okay.
Okay.
Hmm. So next is LGML. This is also asymmetric algorithm. It is an extension of Diffie-Hellman. So I briefly mentioned about Diffie-Hellman algorithm. So Diffie-Hellman is a key exchange algorithm. It is not an encryption algorithm. So what LGML, Dr. Tahir LGML was the mathematician behind developing this standard, and it is industrially wide used. Okay. So what Dr. El did, he never patented his algorithm, and it is openly available, and many of the commercial softwares are still doing it. So it is an extension of or build on Diffie-Hellman algorithm. So Diffie-Hellman was a key exchange algorithm. The
Mm-hmm.
other algorithm is elliptic curve. Okay. So again, these algorithms are based on typical mathematical programs. Okay, so this was also developed by two mathematicians, Neil Cobbles and Victor Miller. So yeah, like I said, Diffie-Hellman is a key exchange algorithm. It is not an encryption. So many people confuses Diffie-Hellman as a cryptography algorithm as well. Okay, so you need
Mm-hmm.
to be clear that Diffie-Hellman's objective is not to do any encryption. It is only key exchange.
Okay.
Yeah, LGML is built on Diffie-Hellman. Okay, so next is hashing. Okay, so I'm taking only high level concepts. Next is hashing. So what is hashing? Hashing cannot be reversed, first of all. Okay,
To
I will I
calculate.
will I will tell you. See, that is called rainbow. Okay, so rainbow
Mm.
table is there where you can get a password from hash. Okay, see how hashing works is hashing is a one-way function. Okay, first of all you
Mm-hmm.
need to remember it is one way. Hmm? So there are five
Okay.
principles of how hashing works. Let me tell you those, then you will have a better understanding. So input can be of any length. Let's say you want to encrypt, or sorry, generate a hash of this book. Okay, you
Mm-hmm.
can do it. If you want to generate a hash of 1 TB data, you can do it. If you want to generate a hash of 2000 TB data, you can do it. Okay,
Mm-hmm.
and the output will always be fixed.
Mm-hmm.
Okay, so let's say you have to generate a hash of this book. Your output will be 128 bit long if you are using SHA or any other. So if you are using SHA 256, your output will be 256 bit long. You got it? Let's say
Mm-hmm.
you hashed 2000 TB data and your output is 256 bit. Can you reverse it? Never.
No.
Okay. So
Mm-hmm.
hashing is always one way. You need to remember it. The thing you are mentioning that you put hash and some websites tell, so that is called rainbow. What they do is, so let's say I generate a hash of your name Atik. Okay,
Mm-hmm.
and I'm using an algorithm called SHA, secure hash algorithm. This one, SHA, secure hash
Mm-hmm.
algorithm. So if you use this algorithm and generate hash of your name, you will get a 256-bit output. Okay, if I do the same for with your name, I will get the same output. If someone third person do it with your name, he will get the same output. Okay, so hash will always generate same output for a same input.
Mm-hmm.
Okay, either you do it or I do it. Okay,
Okay.
so what Rainbow do is, there is a password list which is available in online, the most commonly used passwords. Okay,
Mm-hmm.
10,000 most commonly used password like QWERTY 123456789 12345 ASDEFGH ZXC hello at 12 test 123. So these are most commonly used passwords. Okay,
Mm-hmm.
so what some people have done, they have generated hash of most commonly used passwords and maybe 100,000 most commonly used passwords. Okay, so it will cover 30-40% of the data,
Okay.
and that table is available online. So other way is, they do a brute force on this. Do you know what brute force is? Brute force is making combinations. Okay.
Yeah, I'm familiar with that term, but not clear what it do.
Yeah. So brute force generally is an attack to crack a password. In that, what they do is they do all the permutation and combination what your password or PIN can be. In hashing also they do that thing. They will start generating hash for any particular number. Say let's say you have an OTP. OTP is generally a 4 digit. Okay.
Mm-hmm.
So and the 4 digit combinations are limited, right?
Mm-hmm.
If you do all the combinations of any 4 digit letter, it will get limited to maybe 1 million combinations or 10 million combinations. Okay, so what they do, they generate the hash for all those combinations and store it somewhere. Okay, and then they start matching it. So this is how this reverse engineering works for hashing. But there is no way in this world to reverse an hash function. Okay, okay, so we were here, input can be of any length and output has a fixed length. Okay, so let's say if you want to generate a hash of letter A, okay, or hash of number 272, the output will also be 256 bit or 128 bit depending on the algorithm you are using. If you
Mm-hmm.
want to generate hash of this book, it will be 128 bit. If you want to generate hash of 2000 TB data, it will be 128 bit. Okay, either it is one single character, one letter, one word, one book, 1 TB data, 2000 TB data, it does not matter, output will always be fixed. Okay,
Okay. Okay.
and generating hash is relatively very easy. Okay,
Mm-hmm.
just you apply that function and you will get an output within few microseconds.
Okay.
The next is hashing is one way. Okay,
Mm-hmm.
meaning it is extremely hard to determine the input when provided with the output. They are saying
Okay.
extremely hard. Okay, they are not saying it impossible, because reverse engineering, like you said, can be done, because hash of letter 2 will always be same, either I generate it or you generate it. If someone's
Mm-hmm.
password is common, hello at 123, then getting their hash is very easy. Okay,
Mm-hmm.
then the hash function is collision resistant. So collision is one word when it comes to hash. So collision is when any algorithm starts generating, you need to listen very carefully what I'm saying. When any algorithm starts generating same output of different input, it is called collision. So let's say I enter 272 and 273 and the output I get is same. This is called collision. Okay.
Mm-hmm.
So as soon as collision is there, that algorithm is no longer used. Whenever it is identified that any particular algorithm is generating a similar output, then we stop using that algorithm. Okay, and the same is with message digest 5 algorithm, MD. Okay, MD5, so it has started generating collisions, so it is no longer used in most of the organization. There are still older technologies or older applications who are using it, But in newer applications or more secured applications, MD5 is not used, only SHA is used. Okay.
Mm-hmm.
Read this line. Bottom line is that hash function create a value that uniquely represents the data of the original message but cannot be reversed or dehashed. There is no way ever generated or ever discovered or ever invented to reverse a hash. Okay, you can do reverse engineering, you can do rainbow tabling, but you cannot reverse any hash. Okay.
Okay, got you.
Yeah.
So technically, it's not possible.
No.
Whatever the rainbow table do or the other method do is just
Yes.
probably sort of best guess, right?
Right. Exactly right. Okay.
Okay.
So this is what you have to remember for hashing. So these
Mm-hmm.
are some of the algorithms of hashing. Okay, HVAL, and then HMAC, then MD5, SHA. There are multiple versions of SHA. So SHA
Mm-hmm.
256 and above is the most used ones. Okay,
Mm-hmm.
so prior to this are not used. This MD5, SHA1, SHA2. SHA2 is used, but in SHA2 also 256 and above is used in industry. Okay, so
Mm-hmm.
these are some other standards. Some of the organization uses it, but not widely used. Okay. Okay, so then comes the digital signature part. So, Mr. Atik, I will take 5 more minutes, then we will close this demo. So, what
Mm-hmm.
is digital signature? How do you identify? Let's say you are claiming that you are Mr. Atik, but
Mm-hmm.
I don't know if you are actually Mr. Atik or someone else.
Mm-hmm.
Okay, so I will challenge you to claim that please prove to me that you are what you are claiming to be.
Mm-hmm.
Okay, so how will you claim digitally? So for that purpose, digital signatures are used. Okay, so digital signatures is a combination of hashing and asymmetric cryptography. Okay, so we use both these technologies in digital signatures, then we generate one digital signature. Okay, so that's why I explained public key cryptography, asymmetric and hashing function. I have not yet discussed about public key cryptography. Okay, so let me give you a brief high level overview what public key cryptography is. So right now we both are connected to Zoom. Okay,
Mm-hmm.
and this is the web page open. So let's see what Zoom says about public key infrastructure. Public key infrastructure is related, or PKI we call it in short form, is a way of securing our data, the communication we are doing with each other. The channel we both or we all are connected is secured. How is it secured? Okay, it is saying connection is secured. So it is
Mm-hmm.
secured through asymmetric encryption and symmetric encryption and digital signature and hashing. So it is using everything what we have studied till now. Okay,
Mm-hmm.
and how this browser knows that this connection is secure? Because what they have done, what Zoom has done, Zoom has registered the certificate they are using with a public authority. Okay. And that infrastructure we call it public key infrastructure, and the organization with whom they are registered is called a CA, certification authority. Okay,
Mm-hmm.
so now let's see what CA does. Hmm? It is saying certificate is valid. So what certificate is and how does it look like? Okay, so first of all, we see that the organization we are connected to or the certificate is issued to is zoom.us. Okay, and the full name of their organization is Zoom Video Communication. So whenever we do any secure transaction or secured connect to a bank website or any of the secured website, we need to check if the certificate is valid, because someone can get uh, the certificate similar to it and they can add 30 to it, or double Z double O double M, Z double O double M. Okay,
Mm-hmm.
such type of certificates can be issued and those websites are fake. So how this certificate is issued? This certificate is issued through public infrastructure by a certification authority. And who is the certification authority here? The certification authority is DigiCert. Okay,
Mm-hmm.
and this is the certificate they have issued, and this is the public key. Okay, you were saying about public key. So this public key is available online. Okay, anyone can see it. This is how browser does it. Then What is the hashing algorithm they are using? They are using
SHA, yeah,
SHA
256.
256. Okay.
Yeah.
So now let's see in detail. So whenever a certificate is issued, it is issued as per a standard. So standard, the certification authority uses X509. Okay. So what X509 says is all these things should be there. So certificate is having a version, it is version 3. It should have a serial number. Signing algorithm, what algorithm they are using is SHA 256 and RSA encryption. Okay.
Mm-hmm.
We have studied RSA on high level only, but we have seen that
Mm-hmm.
RSA is some type of, which type of encryption it is? It is
RSA.
asymmetric. Okay. And who issued it? It is issued by DigiCert, and
Okay.
they are using TLS, transport layer security. What is the validity? It is valid from March 28 to April. Okay. So now their public key info. What is the public key algorithm they are using? RSA. This is subject's public key. Okay, Zoom's public key is this. This certification ID, subject key, alternative name of subject is Zoom. Okay, we have seen Zoom's public key is available here. Okay, so this is
Mm-hmm.
public key of Zoom. What is the size of this public key? 2048 bit. Okay.
Mm-hmm.
So other information was CRL, certificate revocation list. Okay. So we'll see what is certificate. Whenever a certificate is revoked, or let's say misuse has been happened, so the certificate goes to certificate revocation list. Okay, and
Mm-hmm.
every time a website is opened, the URL is checked if this certificate is there in certification revocation list or not. Okay, so what they are using for fingerprints? Fingerprint is digital signature. Okay, they are using
Mm-hmm.
SHA 256 for digital signatures. Got it?
Got it.
So now let's have a, we have 2 3 minutes left. I will give you a brief high level. Okay, so this is what we have seen. In our training, we will discuss them in detail, but right now I will show you only high level. So we have seen what certificate is. Certificate is issued as per X509 standard, and we have seen the version. You remember version 3 was there? Right?
Yes.
Serial number was
Yeah.
there, algorithm was there, issuer name was there, validity period was there, subject's name was there, and subject's public key was there. We saw everything. Okay. And these are CAs or certification authorities.
Mm-hmm.
This certificate was issued by this certificate I show you was DigiCert. Okay, Zoom certificate. So there are hundreds of other certification authorities. These are the few one they have mentioned here. Okay.
Okay, so I have a quick question here. So every organization can have their own certification authority, right? Or
See,
no?
there are two, yeah, there are two type of certification authority. One is public. Okay, that public certification authority we count it under PKI, public infrastructure. Okay, so one is publicly available certification authority which you and I outside your organization can trust and authenticate. Okay, see, Zoom everyone is using throughout the world. So if Zoom has to get a public certificate so that anyone throughout the world can uh,
Okay, okay.
trust that.
I think I understand now because
Okay.
I recently changed certificates for one of my app, and that certification came from my own
Yes.
company
So
certification
yeah, that's
authority.
what I'm saying. To save money, see, every certificate cost money. So this certificate which Zoom is using, maybe it might be of around $1,000 per year,
Mm-hmm.
or maybe even more. It depends on the usage. Okay. And so let's say your organization is having uh, 10 or 20 or 50 or 100 internal communication channels or internal sites which they want to encrypt. So what they can do, they can either generate self-signed certificates or they can create their internal certification authority. Your IT team or security team can own
Mm-hmm.
this certification authority, and this certification authority can generate certificate or certify certificate on organizations behalf. Okay, But you need to keep in mind that those certificates are trusted only within your organization. If you open that URL outside your organization or on a public domain, you will get an error that this certificate is not trusted. Okay.
Okay, yeah, I understand. I think you answered the question because as soon I answered I asked the question, I realized whatever application I'm referring here is just used inside the company, no public facing. So I understand. Thank you.
See, public facing websites will have to use public certificates, okay? And these are some of the certification formats. They are generally four standards. These are industry-wide standards: DER, PEM, PFX, and P7. So some are in binary format, some are in text format. So if you want to reopen a P7 B file, you can see it. But if you want to open a PFX or P.P12, you will not be able to see it because it is in a binary format. Okay. Okay. So whenever we use any communication online, we never use only either asymmetric or symmetric or hashing. It is a combination of all which is used for communication. Okay.
Mhm,
Because symmetric communication is fast, asymmetric is slow. Asymmetric is almost 10,000 times slower than symmetric. Okay.
mhm.
So that's why we use a combination of all, and that is called hybrid cryptography.